Hey students, Mr. Danahauer here. Today we're going to talk a little bit more about waves. So in our last lesson, we were just learning the concept of waves. Remember, waves are just a transfer of energy. And so in our energy unit, waves are a big part of that because waves are just a transfer of energy from one place to another. And there's different kinds of waves. So you might remember we talked about longitudinal waves and transverse waves. So sound waves like you're hearing now are an example of a longitudinal wave. And you might remember that one of the characteristics of a longitudinal wave is that the wave direction and the particle motion, so the particles that are moving in the wave that are transferring energy, those things are parallel in a longitudinal wave. But in a transverse wave, like a water wave, the direction of wave motion is perpendicular to the motion of the particles. And so we're going to talk a little bit less conceptually today and a little bit more doing a little bit of math with these problems. Oh, also you learned about electromagnetic waves, how we have the electromagnetic spectrum. And a key thing from today that you should remember from that lesson, and hopefully you're pulling your wave notes out because those will help you today, is that all electromagnetic waves travel at the speed of light. And we'll write that down in a little bit. So on to the actual lesson for today. So again, we're going to be using this equation. This is called the wave speed equation, or just the wave equation, however you want to call it. And it is C equals lambda F. If you would, take out a piece of paper and a writing utensil, and we're going to jot down a little bit of information and do a few practice problems together. So pause for a second while you do that. And now that you have that out, let's go ahead and write this formula down. C equals lambda F. Okay, so write this guy down. And then I'd like you to take a second to label what do each of the variables mean in this equation and what are their units. That's really important. And all that information is down here. So as you're writing, I'll go through that. So first, the letter C in our equation is just the speed of the wave. Like how fast is the wave moving? And the units for that are always going to be meters per second. How many meters does this wave go every second? All right, so we're going to use that. Now you might see, if you look up other waves or find information about waves for some reason, you might see other units used, maybe miles per hour. But in all of our problems, we're going to use the same units, meters per second. Okay, the next variable in the equation is lambda. This is a Greek symbol. Remember, we've used a few Greek symbols like delta in math, which means change in. That's supposed to be a triangle. Sorry, I'm using my finger to write on here because when we got our new computers, we don't have stylus anymore, and so it's really hard to write. So I apologize in advance for my sloppy writing as you go through this lesson. Okay, back to our Greek symbols. Remember, you've used this for partial charges like partial positive and partial negative charges. And then we use the p symbol for to denote density in the density equation. So we've seen some of these. Lambda is a new one, and it's used in science and math a lot. And particularly, it's used to indicate that we have a wavelength of a wave. So remember wavelength, if we draw a wave here, right? Right. Wavelength is in meters because it's a distance. It's just telling us how big is this wave from one crest to one crest, or we could measure it from a trough to a trough, or really we could go any cycle, a full cycle of the wave. So if I started here and I just traced this until I got to that same point and completing one cycle, right, that would be there. So any of those measurements would be wavelength, and we'll use meters. Again, we can use lots of different things. So in the future, you'll see waves measured in maybe millimeters or micrometers, even nanometers sometimes, depending on the size of the wave. And so we'll see different units of that. But for today, we're just going to be using meters. Okay. And then the other variable in our equation is F, which stands for frequency. And remember, that's how often does a cycle of a wave pass a certain point every second. And our units for that are going to be hertz, which really just means cycles per second. Or we might write that 1/seconds. Okay. All right. So you have that down. Now let's go ahead and talk about one more thing before we actually get on to practicing with some of these. And that is going to be the procedure that we're going to use to solve these problems. Now, I'm going to go through this, and I know some of you are going to be thinking, why would we write all this stuff down? That seems silly. It's a waste of time. And so I'm going to give you a couple of good reasons why you want to go through this. Number one, and the one that I think is most important, is if you get into the habit of using this procedure, it will easily tell you which equation you want to use. Now, for now, that doesn't seem important in our class because we've only used one other equation, the density equation, and now this new equation, right? But as you move farther along in the class, we're going to have more and more equations. And in other classes, like physics, you might have 15 different equations, and each of those equations might have similar variables in them. So by listing all of the first step of this is listing the knowns and unknowns, it really helps us choose the correct equation that will get us the information that we need with the information that we already have. Okay, so step number one, whenever we're doing this, oh, I forgot to give you the other reason. Sorry. The other reason that might be more important to you, that's really important today, is that if you want credit for your work, you need to show me this procedure because I want you to get into the habit for the previous reason I mentioned, and you probably want to get the credit for your work. So as we move forward, if you just write down the answer to a problem or you skip some of these steps, I won't be giving you credit for those. You need to go through all the steps of this. So again, number one, right, is to identify the knowns and unknowns. When we read the problem, what do we know and what are we trying to find? We'll list that out. I'll show you in just a second. Number two, from that information, what equation are we going to use? Now, I'll give you a hint. In this, we're always going to be using this equation that I just showed you back here, right? Because all of these problems have to do with waves. But as I said, in the future, it might help you pick the correct equation. Now, we need to look at the equation and go, what are we looking for? And do we need to rearrange the equation? Yes or no? Just a reminder, if a variable that we're looking for is by itself, like C here, on one side of the equal sign, and there's no other numbers or variables next to it, then we can just use that equation. We don't need to manipulate it. But if we're looking for something like F, all right, it's being manipulated, it's being multiplied by the wavelength, and so we're going to have to rearrange that equation to solve for F, and we'll show you that in just a second. So that's step two. And then step three, of course, plug in the numbers and solve. All right. And make sure that you include units. That's going to be important. Every time you write a number down, you should have units on that. So those are the three steps. Let's get on to seeing how we use those. All right. So I have an example problem, and I'm going to come over to the whiteboard for that. So here we go. Let me zoom in there. All right. So our first example is a wave has a frequency of 17 hertz and a wavelength of 0.2 meters. What is the speed of this wave? So let's start out with that procedure that I told you about. All right. So we're going to list knowns and unknowns, and I just put KU here. What do we know? Number one, we know that this wave has a frequency F, a frequency F of 17 hertz. Okay. So I'm going to write that down with the units. We also know it has a wavelength of 0.2 meters. So I'm going to put lambda is 0.2 meters. And what are we looking for? What is the speed? So we know we're looking for C here. I'm going to write that down with a question mark. That's just to indicate, okay, that's the thing that I need to solve for. So that's step one. That's the first part. And I want to see that in all of your problems that you work today. List the knowns and unknowns, right? And it's also helpful. Keep your work organized here. You'll see I kind of have a procedure I go through on these three problems to help you out, just to see how it works. And the more organized your work is, the easier it is to go back in and find a mistake or make sure that you're doing things correctly. All right, let's go ahead and do step two, which is to write down the actual equation. As I already told you, it's C equals lambda F, all right? Speed equals wavelength times frequency. Now, the next part of step two is, do we need to rearrange this equation? Well, I'm looking for C, and C is already by itself, and so we don't need to rearrange this equation. We're good to go. Now we just do the next part, and we're going to go ahead and plug in our numbers. Just a little habit I have, anytime I plug in numbers, I always use parentheses. So I'm going to put lambda there and F there. It's just something I do. You don't have to do that, but it helps keep things compartmentalized. And when you have lots of numbers, like if you're doing chemistry and you have 6 variables you're filling in or something, it helps to keep things just contained and a little easier to follow. So, all right, wavelength for this is 0.2 meters. Remember, I'm putting my units in here. Frequency is 17 hertz. And so I have my numbers in. I'll punch that into the calculator. And if you go ahead and do that really quick, you should have out your calculator. If you don't have that yet, if you don't have it out yet, take a second and grab that. So we're going to punch these in together. Okay, and our answer here, when you plug that in, you should get 3.4 meters per second. Now, a couple of things to check. The main thing to check here is, did you do your units right? So if we just forgot about these numbers, don't even worry about the numbers. What about the units? What should I get here? Well, if I multiply, I'm multiplying these two numbers together, which means I'm multiplying the units together. So I'm doing meters times hertz. And so that would just be meters hertz or hertz meters if we had those units, but that does not equal meters per second. So how do we get that? Hertz is cycles per second, and it's also written as 1/seconds. So now if I write this out, I get meters over seconds, and that's the units that I have here. That's a good check. Now, if your units work out correctly, then that's a good indicator that you did the problem correctly. If we came down here and for some reason up here and we ended up with just meters, I'd go, well, wait, meters is for wavelength. Meters isn't used for speed here, and so I must have done something wrong. But we ended up with meters per second here, so we're in good shape. Also, when you finish your problems, if you would, let me see if I can take those off. Okay, if you would just come in and circle your answer. All right, as these problems get a little more complicated, there's going to be a lot of numbers and a lot of math, and so it's hard for me sometimes to see your work versus your answer, and so please circle those as you go through. Okay, that is problem number 1. Let's go to problem number 2. Step it up a notch. All right, so example number 2, I have a wave. It's traveling at a speed of 256 meters per second. It has a wavelength of 32 meters. What's the frequency? Follow the same procedure. So we're going to list our knowns and unknowns. All right, we know that the speed is 256. Oops, I forgot to write my C there. 1 second here. Let's move it over. Okay, so C equals 256 meters per second. Now it doesn't say speed up here. And so if you're like, well, I don't know if that's the frequency or if it's the speed, look at the units, right? It's meters per second. That's a speed unit. And so you could easily tell by looking at that, right? Okay, now what else do we know? It has a wavelength of 32 meters, pretty easy to indicate there, or just to find that. And so we're going to rate wavelength as 32 meters. And now what are we looking for? The frequency. So F question mark. That's what we're looking for. All right, good. Now we have step 1 done. We have our knowns and unknowns. Again, I could look here and go, okay, well, of all the equations I have of the whole 2 that we have right now, which one has those 3 variables? That's what I need. And so, of course, I would look and say, all right, C equals lambda F. That's the wave speed formula. All right. Now, again, if we look at this, we need to decide, is this set up or do we need to rearrange it first? And in this case, we do need to rearrange it first, right? Now, so I'm going to go ahead and do that before we put numbers in. I want to solve for frequency. I need frequency here, right? That means I need F by itself on one side of the equal sign. So I have to get rid of lambda. Well, how do we do that? This is just algebra, right? This is like algebra 1 or pre-algebra stuff. We're just manipulating equations. So pretty easy stuff. In order to do this, I need to look at what's being done to F. Well, it's being multiplied. Lambda and F are being multiplied. So to get rid of lambda or to move it to the other side, I'm going to divide by lambda. What does that do? Well, anytime you have one thing over itself, like 8 over 8 or x over x, that's just equal to 1, right? And so we have lambda over lambda, which is 1, so they cancel. And I have 1f, or just f. But in algebra, you guys know, we can't just do one thing to one side of the equation. We have to do it to both sides to keep the equation balanced. So I'm now going to divide this side by lambda. And now if I rearrange this a little bit, I can say frequency is equal to speed divided by wavelength. Okay. And again, it doesn't matter what side my f is on in my c over lambda. I can write it either way, right? Here it's written one way, and then below it's here it's written another. It doesn't really matter if that's confusing to you. Those two things are equal to each other, no matter which side we put them on. Okay, last step. Let's plug in our numbers. And speed is 256, all right, meters per second. Pay attention to when you put these in that you're putting them in the right order. In this case, speed came first, so it's easy. Wavelength is 32 meters. And now if we just look at our units here, I have meters on top and meters on bottom, which means they're going to cancel. And I'm going to be left with 1 over seconds, which is the same as hertz. And so am I looking for a unit, hertz units? Yeah, because that's what the units are for frequency. So again, that tells me I have this probably set up correctly. All right, when you plug that into your calculator, you should get 8. All right, I want you to plug that in. Make sure you get 8 hertz. And again, if you would, please circle your answers. All right. So please, again, keep writing these down with me just so you have some examples to use. I know mine's getting a little messy here, but it's great to have some examples to go back to in case you're not quite getting it when you do the practice in a minute here. All right, let's go on and do one more practice problem that you're going to write down, and then you'll get to do some practice on your own. Here we go. I have a wave. So I made a mistake when I wrote this problem and I forgot my units. And so if that ever happens and you're like, I don't know what the units are, just assume, if it's in my class, just assume if we're working with waves that we're going to be using all the units that I already indicated at the beginning of the slideshow there. All right, what do we know and what are we looking for? So we know we have a frequency of 3.7 times 10 to the 12th, and that's going to be hertz because that's the frequency units we're using. That's a point right there. So I'm giving you some scientific notation numbers because that's often what we see in these waves is scientific notation. They're big and small numbers. And so you're going to have to remember how to use your calculator with that. So we'll practice that. And we know our speed is 5.9 times 10 to the 7th. And because it's speed, I'm going to assume it's meters per second. What are we looking for? The wavelength. Question mark. All right. Good, step 1 done. Step 2, write down the equation, right? Speed equals lambda wavelength times frequency. Do we need to rearrange it? Yes, because we're looking for lambda here, and it is not by itself. So how am I going to move that f? Well, they're being multiplied, so I'm going to divide both sides by f. F cancels over here, and I'm left with the wavelength is equal to the speed divided by the frequency. Okay? All right. Now we just need to plug those numbers in, kind of big numbers, right? So also, again, in this example, frequency came first, but frequency is on the bottom here. So we got to make sure that we put them in the correct order. It's an easy, I've seen that mistake a lot. You just put the numbers in order, and then unfortunately, sometimes we get the wrong answer for that. So speed of this wave is 5.9 times 10 to the 7th meters per second. Please put your units. And then divided by the frequency, which is 3.7 times 10 to the 12th hertz. Right? Again, hertz is 1 over seconds, and that means I have a seconds up top here and a seconds on the bottom, and those cancel, and I'm going to be left with meters, and that makes sense because I'm looking for wavelength. Please take a second, plug that into your calculator. All right, I want to make sure that you're plugging that in correctly because this is a good indicator if you're using scientific notation correctly or not. And I will just take a second, and over here, if you're using a TI, Texas Instruments with that EE button, you're going to punch it in like this, right? You're going to do 5.9, you're going to use the EE symbol, and it's going to give you this for a lot of your calculators, not everybody. And you're just going to put the 7 there, right? That's what it should look like. And then you're going to do divided by, you don't have to hit enter. You just do 5.9 E7 divided by 3.7 E12. All right. So that's what it should look like when you put it into your calculator. If you have a Casio or one of the other ones, I know it's going to be different. I'm just trying to hit the majority of the crowd here. All right, when we punch that in, hopefully you got 1.6 times 10 to the -5th meters. All right. If you got a different number than that, and you have the same setup up here that I have, then you're probably not using scientific notation correctly. And you might want to go back to your notes for that, and make sure that you're doing it correctly. All right. Also, if you don't know how to do that in your calculator, there's probably like 1,000 YouTube videos that could show you real quick, based on your style of calculator. So feel free to look that up. Okay, those are the three practice problems I wanted to go through with you. So now here's what's next. I'm going to have you're going to receive a practice sheet that has 4 practice problems on it. So take a little bit of time to work through those, being sure that you follow all the steps that I've indicated here, please. All right. For each one, do those steps, circle your answer. When you're finished with those 4 problems, please bring them up to the person who you're working with, the adult in the room, and they will check your answers. If your answers are correct, they'll trade you for the homework or assignment, whatever. You'll probably just get it done in class. They'll trade you for that, and that's the homework that you should complete front and back, before you come to class next time. If you don't get one right, they'll give you a little bit of feedback on which ones you need to relook at, and then you can do that. You need to get all 4 of those correctly completed with all of the work and everything before you receive the sheet with the extra practice problems that I'm going to collect and grade. That's all I have for you now. I hope you have a great day. Let's go Ridge.